Hi everybody, we're going to solve a combination circuit today, and it's a fairly simple combination circuit. You'll see here we have branch R2 and branch R3 are both in parallel, but before that all of the electrons have to travel through R1, so R1 is in series with both R2 and R3. To get started we'll need to find the R total, which means that if two branches are in parallel, we use parallel rules, and then if those two branches are in series with something, we would use series circuits rules. R2 and R3 are in parallel. To find R total, then we'd use R2 to the negative 1 plus R3 to the negative 1 in brackets, and then invert that, so that's to the negative 1. All of that would give us our R3 value. 40 to the negative 1 plus 40 to the negative 1. Invert that, and we're going to end up with 20 ohms. What I like to do is an equivalent T. So I draw it like this with a little ziggly line showing that it represents more than one branch. And in this case we said that 1 over 40 plus 1 over 40 is going to give us 20 ohms as our equivalent. And then, because R2 and R3 are in parallel and they are in series with R1, we just add the 5 ohms to the 20 ohms to get our total. Our total then would be 25 ohms. Now if you look over here in our total T, we have 100 volts divided by 25 ohms, which would give us 4 amps total for this circuit. We know what comes out of the negative in electron flow, and our 4 amps goes down and goes through R1. Now we have two numbers at R1. 4 amps times 5 will give us 20 volts at R1. If I have a closed loop and our source, our 100 volts, is always shared in any closed loop. So the closed loop for this example is around here. That's one of our closed loops. That means that this 20 volts plus the value of R2 has to equal 100 volts. So then we know that 20 plus 80 would give us 100 volts. R2 then is 80 volts, and 80 divided by 40 tells us that there's 2 amps flowing down here. At this junction or node, if we use Kirchhoff's current law, we know that 4 amps flowing into that junction and 2 amps flowing down through R2. The remaining 2 amps has to flow through R3. So we have 2 amps flowing through R3, which 40 times 2 amps would give us also 80 volts at R3. And that makes sense because resistances in parallel have the same voltage. We can check with another closed loop, this larger closed loop, and you will see that 100 volts with 20 volts at the first resistor and 80 volts at R3 also equals 100 volts. So for that closed loop we also are within all of the rules.